So like any other subject that you study, there's history behind it, and chemistry is no different. So the goal of this video is to really visit the origins of chemistry pretty far back, and we're going to stop around the time of, we'll say around the 1600s or so. We'll pick up later in another video. So chemistry has a past, and let's take a look at it. So when humans were first inhabiting the earth, right? The cavemen, really that was later on. Before then, we'll just call them the earliest humans, right? They manipulated matter for survival, right? To make tools, to kill animals for food, for basic shelter, right? So they used the things that were naturally provided for them via the earth for survival, right? And as civilization slightly progressed, they were able to manipulate matter for more slightly advanced items. Now, we don't think of pottery or basic metalworking or even dyes as slightly advanced, but it was compared to what it was earlier in time. So the early civilizations, they figured out that they could also have fire, right, which was a big deal. Herbs, right, for medicinal purposes. Alchemy. Alchemy is a fake science. In fact, it's not a science at all. It's the idea of, well, we can turn dirt or, even aluminum into something valuable like silver or gold. And we'll talk about that a little bit more later on. And then civilization progresses even further, right? So civilization is progressing as we are going down here to the ancient Greeks. And at this point, the economy was pretty good for that area. They were in relative peacetime, right? And so it was more of a plentiful time where it wasn't just focused on survival. They could start asking some more philosophical questions, right? If you think about it, we oftentimes associate the ancient Greeks as the ancient philosophers. And so they could just kind of think, well, this piece of pottery that we've been using for a couple hundred or a couple thousand years now, what's it actually made of? Or what gives this piece of metal its properties to conduct electricity? Or why is it so strong? So they can start asking why. And then after the ancient Greeks, we really didn't progress, but time progressed, right? And we went into the Dark Ages, where there was a period, I call it sin, sickness, and alchemy. And again, alchemy is that pretend or false science of creating something from nothing. Now, there are some good things, by the way, that came out of alchemy, just not proportional. They wasn't good proportional to the amount of time that it predominated in scientific theory. But we'll talk about that a little bit later. And then after the Dark Ages came the Enlightenment period. So again, some things came good, or some good things came out of the Dark Ages, such as the Enlightenment period, which undoubtedly has led to this era in modern chemistry, right? All right, so let's start. We're going to pick up right here with the ancient Greeks, right? The earliest humans, the ancient civilizations. I mean, that's, we're not going to study fire and pottery, really. So let's move to the ancient Greeks, because this is where the very beginning of modern atomic theory, this is the beginning of the thought of atomic theory. And it starts with a man named Democritus. So he was an ancient Greek philosopher, and he lived around roughly 400 BC. And this is really what Democritus did on the big scale. He speculated the existence of small particles just by thinking, from pure philosophical reasoning, right? So we talked about pottery earlier, right? So Democritus was able to look at a piece of pottery, and he was like, well, here's a piece of pottery, right? I can't draw it all. But Democritus was actually able to think about it and analyze it and say, well, there must be tiny particles that actually make up this piece of pottery. And perhaps the way that these particles are arranged might give it its specific properties. So again, he found that conceptualizing matter as if it were made of tiny, unchangeable, or indivisible, right, not divided, particles that could explain their properties, right? So the rearrangement of these particles would be a physical change. So in other words, what Democritus was saying, as I said earlier, right, what makes up something, those small particles, the way that they're arranged, or even what those small particles are, gives it specific properties. So Democritus described the physical world as a combination of two things, void and being. So you're like, what? Let's take a look at a little bit later, or a little bit more. So void is like a vacuum, and a vacuum is empty space. Now it's not like a auric or whatever, right? Vacuum is empty space. And being, he said, an infinity of atoms. In other words, an innumerable number of atoms. So we'll say tons of atoms. And by the way, the word atom comes from this Greek word here that means to be sliced. So this T-O-M-O-I actually means to be sliced. But when you add an A in the Greek language, or alpha, it means cannot be sliced. So the word atom was coined by Democritus himself, and it means something that cannot be sliced. All right. Now, anyway, let's go back and analyze this a little bit more with regard to what Democritus was saying about void and being, empty space and tons of atoms. Right. So Democritus was kind of right, because if you think about it, an atom is actually 98 or 99% empty space. The proton, neutron, and electron actually take up very, very little space. So Democritus viewed the world as just a ton of empty space, but it was filled up with atoms. And that thinking, again, is not bad for 400 BC. He said atoms are indivisible. You can't divide them, you can't break them, and you can't destroy them. Eternal. And again, that's not bad thinking for 400 BC. Nuclear chemistry, in some ways, we can certainly change an atom from one thing to another with some nuclear chemistry. And we'll talk about that later. But again, for 400 BC, it's not bad. So, as any body does, right? Well, we all die at some point, and so did Democritus. Unfortunately, though, Democritus' successor, Aristotle, did not hold to these very good ideas. Frankly, Democritus' ideas were taken by an English scientist, John Dalton, in the 1820s, I believe, and he used those ideas to form the modern atomic theory, or the very basics of it. But Aristotle, his successor at the time, totally believed something else, and we call it false doctrine, or that's what I'm calling this slide. So he rejected Democritus' idea of those small particles and their arrangement making up their properties, right? Or of atoms, essentially. He said that was a load of garbage, and he believed the world was comprised of four essences, and these are very important. Earth, water, air, and fire. And if you look at this diagram here, well, he said, you could take fire and air to get hot, or you could take fire and earth to get dry, earth and water to get cold, or air and water to get wet, or some random combination of these things. And we know this is just awful, right? It's absolutely not true. We went from a very progressive idea, small particles and their arrangement gives them their properties, which was Democritus' idea, to earth, water, air, and fire being the four essences of earth with Aristotle. And that just doesn't work. And if that doesn't, depress you, let me depress you now. This idea, this really, really false idea, lasted roughly 1,800 years, really longer, to be honest. And this time, by the way, is called the Dark Ages, right? And also alchemy, again, this pretend art of making something from nothing dominated. On top of that, so the Catholic Church at the time was very, very influential, right? If you want to think about it in extremely, perhaps oversimplified terms, the plague was going on during the Dark Ages and a lot of political and economic unrest. And so the Catholic Church was like, well, we're going to crack down. We're going to get a little bit tougher. And so the leaders at the time of the Catholic Church essentially said, if you don't agree with us totally, and you don't agree that what the Bible says, or you don't take what the Bible says literal, we're going to punish you, right? And so, God forbid a scientist performed some experiments and came up with an idea that was contrary to what the church leaders believed. There was heavy persecution as a result of that, and I'll have another video posted about that in more detail. You've probably heard about some certain scientists that influenced that, or that experienced that and were even killed. So there was a negative church influence on science. And again, I'm not saying that today that's the case, right? I personally believe that religion and scientists and science can coexist. They go hand in hand. But again, at the time, the Catholic Church said that, you've got to have faith over science. And if you don't agree with us, we're going to persecute you, which is not a good idea at all. And of course, with this pretend art going on and then persecution from the Catholic Church, there was certainly no scientific theory. And that's why alchemy prevailed. And we're not going to do the next slide. All right. So there's a very basic introduction to the history of chemistry, and we're going to pick up with some more videos on the Enlightenment period, which comes right after this.